All right, so this is going to be 4, 1, 2 at the top. And we're going to look at sine and cosine. I'm pretty much going to summarize what we just talked about. I just think it's really important for you to have it in your flip book because there's such big ideas that we're going to build upon. So specifically, how are sine and cosine related to the unit circle? Or how are triangles related to circles? If you want to try your hand at drawing another circle, you can do that. But I bet you can't make it as perfect as mine. Let's take this off. Okay. So divide it up. And we're going to draw the same diagram you actually drew earlier. And we're going to label it pretty similarly. This symbol, guys, I know it's a Greek letter, and some of you might not think the name's important. I'm going to refer to this all the time as theta, so make sure you know what to call this. This is theta. Good, Joshua. That's awesome. Joshua thinks it's important. X over x and y, and then we have our p-value, which is, p just represents a point. And we're dealing with the unit circle, so again, this has a radius of 1. If you ever take like calculus-based physics and you learn about vectors and motion and movement, you use the unit circle to do things outside of that with circles bigger than 1. But it's the same concept, so it's all built here. Or you just learned 2 things. We derived 2 things. We figured out that cosine of theta is equal to x or y. Is your x-coordinate, right? And then we figured out sine of theta is equal to your y-coordinate. And I will tell you, students mix these up all the time. Why do you think they mix the 2 up? They think sine is with x and cosine is with y. It has to do with order. Because you know when you graph something, x comes first? Students usually think sine just comes first. It's like sine, then cosine, x, then y. Yeah, it's kind of the opposite. So somebody in my first period said, oh, it's just alphabetical. Cosine and x come before sine and y. It's like x, then y, cosine, then sine. So that might be a way to think about it. Cosatoa? Yeah, I guess you could create a new acronym. You got to teach it to your geometry teacher, though, because that's where you learn it. Okay, so those are the 2 big ones. And then the third one is that identity, and we'll go ahead and write it on the right side. So the Pythagorean identity and this becomes really useful for us later in chapter 4. You begin with the unit circle equation, which Martin shared with us. For this circle, since it has a radius of 1, it's pretty simple. It's just x squared plus y squared equals 1. Now, after we have that, what did we do with our x and y's? Yeah, we substituted in sine and cosine, right? So we can rewrite this as cosine theta squared. I'm going to write it like Natalie talked about it because I think it's good for you to see. And this is kind of how you'll do it in your calculator, but really how it's written, and usually sine comes first, it's written like this. They're all the same thing, but I want to make sure you write it that way. So this is, we have stars next to those guys. This is your Pythagorean identity. That's really important. And then your last one is what Morgan shared with us. It's tangent of theta. This is equal to y over x, or share with your neighbor, what does it also equal? Sine theta over? Beautiful. Okay? And this is the last one you need to know. Now, The cool thing is we derived all this, so if you forgot, you could figure it all out. But to be honest, you're not going to want to go back and derive these. These four things you just need to memorize. Cosine is x, sine is y, Pythagorean identity, and then tangent. We will learn more identities based off this one that you can rederive, but for these four, you got to memorize them. Yep. To what? Yeah, so that's what I was saying about like calculus-based physics. You all of a sudden you're not dealing with a unit circle that's 1. You're dealing with a unit circle that could be 3.5 or 4, and use what's called a unit vector to base everything off this. So it all starts here, and we will look at some other applications of that.